All right, we are all set. I'm going to drop out and turn it over to you, Kevin.
Thanks, Derek. Hello, everyone, and welcome to the 9th installment of our ProTechTalks series. My name is Kevin Olson, Manager of Business Development for ProTechnics Canada, and I will be your moderator today. ProTechTalks is a series of oil and gas industry expert panel discussions on various relevant and valuable topics. In today's discussion, titled Where the Proppant Meets the Rock, our panelists will provide insights into how geological features impact hydraulic fracturing performance. So thank you very much for our panelists for joining us, and let's meet them. In alphabetical order, starting with Ms. Carolyn Currie. So Carolyn Currie has held key positions as Senior Geologist and Project Lead at Core Laboratories, working on various unconventional plays in North America and globally, including Duvernay, Montney, Wilrich, Spirit River, Eagleford, Marcellus, Midland Basin, and Deepwater Mozambique. She currently serves as the Manager of Rock Properties, leading such projects as the Duvernay, Montney, and Wilrich Spirit River Consortia studies in the Canadian office. Throughout her time at Core Laboratories and previous projects, including her master's project, she has logged, described, interpreted, and integrated 500 plus cores, ranging from unconventional shales, tight sand formations, deep water sandstones, heavy oil, and oil sand cores. Next up, Dan Haider. Give us a wave, Dan. There you go. Dan grew up on the east coast of Canada, studied geology at Dalhousie, where he received a Bachelor of Science with honors in 2008. He moved to Calgary that same year to start working for Encana Corporation as a new graduate geologist. With Encana, he had worked on a number of development, delineation, exploration, water acid gas disposal projects and assets. Prior to departure, he worked on the Montney reservoir characterization team supporting Encana Dawson, Tower, and Pipestone assets. Since 2017, he has been working at 7 Generations, helping the development team and reservoir characterization of the Montney asset in Kakwa. He enjoys traveling, spending time with family, and golf. Next, Justin Kitchen. Justin obtained a diploma on petroleum engineering technology from the Southern Alberta Institute of Technology, and subsequently a degree in petroleum engineering from the University of Wyoming. Out of university, he joined Encana, where he took on roles as a reservoir, production, and completion engineer. Justin then decided to take an opportunity to move back home, which is the Okanagan for Justin, and took a position at the BC OGC. After 2 years, he and his family made the decision to move back to Calgary, and he was lucky enough to find an opportunity at ARC Resources, where he is today. At ARC, he has been involved with multiple fiber projects and diagnostic trials, and most currently cutting his teeth on frac modeling. Justin has also taken the challenge and completed the CFA curriculum. And last, but certainly not least, Mr. Chris Wilcox. He's a practicing geoscientist for the last 20 years, focusing the last 8+ years on the Triassic Montney in BC and Alberta, leading both technical and operational multidisciplinary teams, including reservoir characterization, resource assessment, subsurface development planning and execution for Ovintiv, formerly Encana. Chris is a reservoir advocate for integrating rock and reservoir properties with development strategies, completion techniques, and production with stacked modern diagnostics to understand the 4 dimensions impacting successful Montney development. Thank you to all our panelists. Thank you so much for joining us. Glad you're here. Thank you to all of our attendees as well. Thank you for everyone who took the time to join us today, and we look forward to a valuable discussion. So, as always, we've done 9 of these ProTechTalks so far, and we always start with the same question. We're going to look at it from a geoscience perspective this time, if you will. And the question simply is, from a geoscience perspective, what are the greatest challenges and opportunities we face entering 2021? And maybe I'll ask Chris to open that up for us.
Sure. Thanks, Kevin, for having us. You talk about subject matter experts. I'm not sure that's the case, but the panel will do our best job to start answer some of these questions. So I really do think, what we've experienced the last 6 or 8 months With the COVID and then the challenging market conditions, I think our biggest challenge will be finding capital to develop and advance our understanding of the reservoir, and doing it in an environment where we have limited staff. So being able to manage the data, acquire new data, and then effectively turn it around and leverage that to make better wells. So I think that's our biggest challenge.
And what would you say is our biggest, the biggest opportunity, Chris?
Our biggest opportunity is that the industry as a whole, we sit in the same place right now. So the opportunity would be for us to help each other and build up our industry competitiveness, maybe against some of the US assets. So the industry up here in Canada can survive and thrive. So that's kind of what I would say I'm an advocate for. That's
great. Thank you, Chris. That's great. Dan, I'll throw that over to you. Biggest challenges, biggest opportunities that you see at 7Gen for 2021.
Yeah, I'll kind of echo Chris a bit, I guess, but I had doing more with less and the pressure to cut costs in unconventional assets. That's something I think those of us who are fortunate enough to still be employed, we're no doubt trying to get the same amount of work done with less people on our teams, so and achieve the same if not better results. So we are going to be challenged to innovate while experiencing more workloads.
Okay, good stuff. Carolyn, any thoughts, opportunities, and challenges for 2021?
Yeah, I mean, the biggest challenge is always, promoting that geologic aspect, right? And not leaving it always up to the engineers. And so most of the decisions are being made by, geologists at the, and so, determining analysis and making sure that analysis makes sense and that kind of thing is hugely important. I see that probably as the greatest challenge right now is promoting, okay, I want to take this core, how can I push it through to management and actually, do that analysis, get those answers, so that we can produce wells that are doing better.
Okay. Mr. Kitchen, any thoughts? Opportunities and challenges for 2021?
Yeah, I don't, just not to echo everyone else, but I guess the challenge would probably be, capital to do some diagnostic work. I know some of the big ones are quite expensive, and it's challenging to find the capital. I'm sure for a lot of companies. I mean, us at ARC, we're pretty fortunate with our asset base that we still have a healthy program. So our opportunities are probably some others. Challenges where the busy guys probably have opportunities where we can do diagnostics and progress our learnings. But yeah, so it's kind of a double-edged sword. I think both challenges and opportunities at this point.
Okay, so let me follow up on that question. What is the role of technology and innovation in a low margin restricted cash flow environment? How are you guys making sense for yourselves of wanting to do diagnostics, technology, innovation in this type of an environment? And a follow-up question to that, how do you communicate that to your senior management? And how do you sell yourselves internally the value of doing these projects, which are sometimes, science projects or whatnot? What is the role of them right now? And then how do you communicate them and show the value internally? Anyone want to jump on that?
I'll take the lead on that, Kevin. So it's kind of a two-part question. What's the role of innovation and technology? Yeah. I think it's two parts in there. One is to help us advance our understanding of the reservoir and using multiple diagnostics to sort of stack them together to gain better insights around what's really happening subsurface. So that's one. And then technology, just being open to what's out there and what can we employ to help us better understand or narrow our conditions around what the reservoir is actually doing at the time. So I think those are the things that we have to be mindful of and open to. And then the question around how do we convince our senior leaders to capitalize some of these diagnostics? And I think it's always through showing the value of the learnings. And so from my experience, it's not good enough just to have a pilot or do some core work. I think it has to translate into value for the shareholders. And I think we do that through either making better wells, driving down cost, or improving our predictability of the fluid or the production of the well.
Justin, I know you've been involved in a lot of fiber optic projects and diagnostic technology projects. What are your thoughts on first what the role is in this lower margin cash flow environment, and then selling that internally?
Yeah, so the role is probably, I mean, in lower commodity prices, the role is probably more important than ever in reality, but I can understand, like, finding the capital sometimes is harder to do because it's a bit more tightly held. As far as selling, I think, to echo Chris's comments, you really have to show the value. So it's not a one-off. It's not necessarily this diagnostic for this one well or this one pad. You really got to show how the compounding of learnings can really progress learnings and cost savings or better wells going forward. It's not just one project in a silo. You can really take the learnings and use them widely across your asset base, I think, is of primary importance for sure. Line of sight to, cheaper or better wells, 100%.
Yeah, for sure. Dan, any thoughts on that?
Yeah, I guess, like, I always kind of see new technology as an investment, right? You're not going to invest in something if you don't expect a return on that investment. So, more than ever, it's important we understand what that and quantify what that return is going to be. And just, as kind of scientists or people who are at kind of the forefront of messaging that, you have to make sure that, all groups, all teams are on side and present that case to your management.
Carolyn, any thoughts on helping your clients to see the value in doing some of this stuff?
Yeah, so for, the service side of things, we always got to be conscious what our clients' budgets are to begin with. But just looking at this past year, 2020, and the role of like technology and that kind of thing, like, I think we've seen an explosion of almost technology and different diagnostics and that kind of thing come out of at least the service side of things that have really helped operators, look at the reservoirs in maybe a different way, and maybe a cheaper way too. So trying to get more data out of things that you already have, right? So for example, brittleness modeling and hardness modeling from drilling logs, those kind of things. So it's really, made the service industry, I think, step up to the plate in terms of these diagnostics and making them, more relevant to, the operators and the clients that we're serving, right?
Very good. Well, thank you for those answers, guys. Let's change focus a little bit. Let's talk about well design a little bit. All right, something certainly top of mind for everyone, and really one of the things we wanted to bring to bear in this particular conversation: how do geological considerations impact your well design, as in lateral length, casing design, landing of the lateral section, and so on? Maybe Dan, do you want to weigh in on that? How do geological considerations impact your well design?
Yeah, I can kick that one off. For me, in the question there, you listed landing as an example, and putting your well in the right place, I think is critical. And that's why it's important, to cut core, log your vertical wells, understand what's going on from the facies, the geomechanics, the natural fracture perspective, and what implications all of those features may have on your drilling operations, your completion operations, and finally your well performance. So, tying it all back to that type of information and then high grading landings, in my mind, is critical. And it's something we've, been really focused on at 7 Generations, and we've definitely seen success on the operations side through doing it.
Okay, I see Chris nodding, so maybe I'll see what he's thinking.
Yeah, so I think Dan's spot on there. I might take it a couple steps further, understanding like the structural fabric features of the rock, understanding if you have casing deformation issues, elevated pore pressures, if you have induced seismicity in the area. I think we need to understand kind of breakdown pressures, and that'll drive sort of pump rates, casing design, those sorts of things. The fluid type, what kind of fluid are we looking at producing, and what kind of artificial lift do we need long-term? Flowing pressures, wellhead pressures, what kind of design do we need at the surface for wellheads? And then I think having a pretty good understanding of the phase envelope and kind of how we draw down those wells and maximize those liquids also play into that well design.
Thanks for that, Chris. Carolyn, any thoughts on examples that you've seen and how geological considerations have impacted well design?
So well design particularly, I'm not too familiar with. Like we deal on a vertical basis for the most part, and core, and all of those great analysis that both Chris and Dan just listed. But yeah, at Core Lab here, we are branching out into the kind of the lateral field, and and where well design actually matters and that kind of thing, and it matters a lot. So I mean, yeah, you may have a cored well in a vertical position, but you don't know what's going on a mile out. And so so those are critical things to kind of know, and we're kind of delving into some diagnostic type features and things that we can start helping clients with regarding a mile out from that vertical section.
So I'm going to change the question just a little bit for my friend Justin. And what I want to ask is, how do geological considerations, Justin, from a completion standpoint, how do geological considerations impact your frac design? Stage spacing, frac size, frac rates, and a follow-up question on that. And we're going to pop open a poll question on this. So Derek, let's throw open the poll right now, and we'll let everyone answer. You'll see the poll question has to do with natural fractures.
So you want me to go first while they're polling? So to answer your question?
Let's actually throw the poll open, and then we'll have some folks answer it. And then while they're answering it, you can see, we'll get your answer, and then we'll see if it matches the poll.
All right, it should be up. Can you guys see it now?
I cannot see it yet.
Not yet.
Okay, let me try this one more time.
Oh, there it is.
Perfect. So you can see there, when perforating a well with natural fractures, perforations should target the natural fractures, perforations should target around the natural fractures, are not important enough to merit consideration.
Okay, so I'll answer your question, I guess. So when we get, sometimes we get completions gets involved at certain points in the planning process. Quite oftentimes the wells are kind of already planned. So oftentimes we'll certainly look at landing depth. We have Montney's multi-stack, so going into completions, we'll treat every layer in every area a little bit differently. Obviously, some areas and some layers are similar, but they each have their own consideration as far as how we plan for efficiencies, how we plan for sand delivery, how we plan for our sand ramps and water volumes. So all that comes into play. As far as frac design itself, all our areas and all our all our zones also have varying degrees of tonnages and spacing. That's not necessarily, or even at all, just the completion engineers. That's usually very much a interdisciplinary process for the most part, and then some obviously get to standard. But yeah, I mean, every layer in where we work in every area is different. And as far as what Chris is saying, then we get into induced seismicities where we need, sometimes you need backup wells, you could call them. So we have certain zones that have higher induced seismicity. And if we're gonna get landowner complaints or whatever, we might need to buy some time for that. That comes into play, and certainly casing deformation. So we run into it in our acreage in some spots where we get deformed casing, and we need to plan around as far as contingencies, frac orders, plugs, all that stuff. So geology, certainly plays a huge role in what we experience and what we plan for. We probably don't know all that we could going into it. A lot of it in the past has been just experience-based. I think industry and ourselves, for sure, we're trying to get better at understanding it before we go into it, other than just saying, oh yeah, last time this zone did this. Trying to understand it better and plan around it, and really communicate interdepartmental, I guess, some more. But
yeah, I think Justin's absolutely right. Like, step one, I think, to addressing this question is just characterizing your fractures and your stress regime. And you're going to get different answers depending on the conclusions you draw from those results. At 7G, we have a zone that tends to be prone to more horizontal slip faces and vertical fracturing, and we see more challenged achieving higher pump rates in that zone. So of course, pump rate is a key parameter in your per friction equation. So that that's going to impact how you design for your limited entry or your extreme limited entry. But to me, it all comes back to that characterization and what do you think your fractures are doing to your system at the end of the day.
Yeah, that's a good point. We play with perf design based on which zone of the Montney we're in and acid placements and types of plugs. So yeah, it's all very intertwined. And as far as this question, we don't see the polling question in natural fractures. We don't experience that a lot. For me to answer this, the little experience I do have, I'd say we would try to avoid them, just based on leak off, and you're probably not getting great cluster sand distribution if you're pumping into one natural frac instead of making some man-made ones.
So your thought would be around the natural fractures.
If I had, without knowing anything more, if I had a choice, that's probably what my default answer would be.
Perfect around it. Chris, any thoughts?
Yeah, so two things there. So on the avoid or just plow straight through them, I think it's dependent on, the magnitude, the size, the orientation of these features, how well do you understand them? But in absence of understanding them, I think your preference is to avoid them. I think for two reasons. A, you're essentially going to overcapitalize on that portion of the rock. And so you may not be doing yourself any benefit there. And two is creating asymmetry or SRV that is not consistent across your wellbore. So I think for most cases, we would choose to skip those. And then as far as the geological considerations for frac type, I think, we've come to terms at Ovintiv at looking at a customized design by bench. And a lot of that is driven around the reservoir quality. And so when we start talking single digit nanodarcy rock, we're trying to improve the conductivity and the permeability of that rock. And so we do that through cluster spacing and putting more energy, tighter spacing, higher scope into some of those sorts of single digit nanodarcy type rock.
Good stuff. Carolyn, any thoughts? Anything you want to weigh in on?
Yeah, I mean, I chose the same one as all the rest of the guys here, kind of avoid those natural fractures where you can, maybe to throw the Duvernay into light. The Duvernay is quite naturally fractured and they have very long vertical fractures. So for sure you want to kind of avoid those in order to kind of increase your, your stimulated rock volume. So you're not just hitting one target and that's where all your sand and your proppant is placed, and you want to increase, those complex fractures almost around that as well. So, but in terms of natural fractures, I probably see this as the most unlooked at thing with regards to core. Like I haven't seen an oriented core and I don't know how long, to actually get the orientation of those fractures correct and that kind of thing. And that's hugely important. And when you're looking at your laterals and you want to maximize that SH min and SH max, right? So you got to know those features inside and out. So definitely one thing that I would like to see more of is kind of fracture studies and that kind of thing.
Would you say that's almost like an opportunity for 2021?
It could be, yeah, absolutely.
That's great. So let's see what the poll had to say. Let's see what the audience thinks. All right, pretty good, pretty good. Seems like everyone kind of agrees that we want to be targeting around the natural fractures. So, in order to do that, we need to, as Carolyn said, understand where those natural fractures are and see how we can design around them. So that's great. On that same topic of well design, one trend we're seeing a lot is increased lateral lengths over time. Wells continue to get longer and longer. How do you determine for yourselves the point at which you start to see diminishing returns? How do you evaluate that?
I'll take a stab at that one, Kevin. So a few things that we look at is we're looking for that incremental NPV value when we drill those longer and longer lateral lengths. And at some point, you're going to get to a place where you actually have to change the structural design. And once you see those step changes in costs, that's when you actually meet that rollover point on that incremental NPV. And so we're always trying to figure out, what is the serviceability, or how long can we mill these wells without having to go to jointed pipe? What's the plug selection, whether they're dissolvables or composites? We look at delta P at the toe. Can we get sufficient rate at the toe to create some effective cluster stimulation? So those are all the things that play into it. And as your costs continue to creep up, you get to a point where it's actually no longer beneficial. And so we're always looking to optimize that. And then you take the element of pricing into it, and what can you afford to do? And that's always that balance that you're playing, trying to optimize on all the time.
Chris, at Ovintiv, have you adopted the design of doing plug and perf through the majority of the lateral and then moving to sleeves at the end?
So we've talked about a hybrid design. We're not there yet. We're still able to do some low cost changes to our wellbore design to make sure that we're getting that effective delta P across the toes of our wells. And that might be through more horsepower on surface, might be larger pipe, looking at our fluid viscosity, those sorts of things. And so we have managed that to a point, but it's certainly always on our radar. And we'd like to think that we're maybe fast followers on some of that technology and trying to understand how we employ it in a way that works for us.
Great answers, Chris. Daniel, how about at 7Gen? How do you determine the diminishing returns on lateral length? And I'll follow-up question, have you adopted any hybrid completions, as Chris said, plug and perf with sleeves at the toe?
Yeah, we are investigating or trialing some hybrid designs, I guess, and kind of a loaded question, Kevin, because we're validating some of those using your oil and water soluble proppant tracing.
That was
for flow shirts.
Not the intention, I promise. This is no at all.
Well, anyway, I thought I'd throw the plug in anyways. In terms, one thing at 7G, we're kind of in the foothills. So, surface constraints, kind of dictate where we're able to build surface locations, and, that can be a factor when deciding on how long to extend our wells, or how short for that matter, just to kind of get your optimized pad layout. We have a few river valleys that cut through our field that make things so challenging in some places. So, surface and access is a big one for that field.
Okay. Justin, any thoughts?
Yeah, I'll go to just to echo Daniel's comments there about surface location. So most of our long laterals, like the longest ones we have, I shouldn't say long laterals, but our longest ones are usually for a reason, whether it's our last chance to get that extra couple 100 meters, go in a certain direction, or what have you, because of wells pad already exists there, or we're going to the border of our land, or what have you. Those are usually our longest ones. I don't know if I certainly don't have an answer of what's too long. Usually ours are, we're pushing the envelope, I'd say, a bit, but we're usually pretty reasonable what completions and drilling is comfortable doing. And then, the longest ones are for a reason. Yeah, you get into dissolvables, running tracers, and things like that. And most of our, to Chris's point, a lot of it has to do with commodity pricing, I think, and how you're going to produce these wells. If you're in certain areas where you're choking your wells back for extended periods of time, and commodity prices are low, it might not be really beneficial to have all that extra lateral out there when you consider risk of production and time value of money and all that. So yeah, I don't have an answer for how to determine what's too long, but certainly a lot goes into it.
For sure. For sure. Well, and commodity prices are looking a little brighter today, which is nice. So a couple of follow-up questions on that, talking about hybrid completions. There's a lot of interest, and we'll actually have a poll question on this in a moment. There's a lot of interest, both from attendees and internally, on choosing a completion strategy. Plug and perf versus ball drop versus annular frac. What factors are considered critical, and what strategy do you employ, and how do you high grade this decision? in terms of plug and perf versus ball drop versus annular frac. And a follow-up question that I would have from an attendee in the United States who was interested why we think that sleeves have become very, very popular in Canada and have never really gained traction in the US. Just if you had any thoughts on that, we'd love to hear them. Chris, you want to jump on that one?
Sure, I'll jump on that grenade. So two parts, completion strategy. At Ovintiv, about 7 years ago, we fully committed to plug and perf. And it was really twofold. It was one around getting our costs down to a place where our wells are very competitive. But two, it was the repeatable nature of the limited entry and getting some consistent SRV across our lateral length. And so controlling that and making sure we understand the network that the hydraulic network we're creating. And that kind of feeds into our spacing and stacking development strategy. So really for us, plug and perf, it was repeatable, it was predictable, and the costs were quite competitive. And so we continue to go down that path, but not to say we aren't open to that next technology, whether it's a hybrid design or whatever it is. And then the sliding sleeve question around the US, maybe it's out of my wheelhouse a little bit, but if I were to guess, I would say confidence and cost. I think if it's not cost competitive, people just aren't willing to go there. And so if we can drive down those costs and we can show repeatability, I think you'd probably get more uptake on the technology.
Chris, do you think, are there any geological considerations? Like, is the Montney just a different reservoir than the Permian, and sliding sleeves may work in a more functional way in the Montney? Is there any considerations like that, do you think?
Yeah, that's a total loaded question because I actually think every reservoir is different. And so none of them, whether they're stress, their fluid, their depth, their pressure, their temperature, they all are a little different. And so I would just say that it's the design is always unique to those conditions within that reservoir. So I'll avoid answering that question.
Well,
Ben Stevenson from Shell wrote a paper on this subject, and he was comparing Montney and Duvernay. And I think if I remember it correctly, some of his conclusions were, their economics aside, Montney, because it's, fairly brittle, fairly stiff, high stress anisotropy, you expect very planar fracs.
Brittle then?
Brittle. Brittle. I'm not gonna say the Montney's brutal. It's responsible for my income, but yeah. So because you get these nice planar low complexity fracs, I think he was arguing that sliding sleeve is appropriate for the Montney. Duvernay being a bit more complex, more faulted, like Carolyn said, more natural fracturing. He was arguing for a plug and perf design, but. Anybody who's keen, I would encourage them to seek out that paper because my explanation is probably not doing it justice.
What was that paper again, Dan? For anyone who's
the author is Ben Stevenson from Shell. It's an SPE paper. I don't know the number off the top of my head, and it was the ACTE conference in 2020 or 2019.
Okay. Justin, I know ARC uses various different completion methods. Any thoughts on that? Anything you want to weigh in on?
Yeah, I was just going to weigh in on Chris's, one of his comments. I was waiting for the right time, but his comment about plug and perf being predictable is usually not associated with plug and perf versus sliding sleeves. Anyways, thought that was interesting. Ovintiv took that approach, but ARC is, we're heavily plug and perf limited entry. We also have some assets in Alberta that do sliding sleeves, so we do both, but predominantly we're plug and perf. I think a lot has to do with where you are in the Montney as far as how close you need your clusters. If you need your clusters or fracs to be, close, 10 meters or less or 20 meters or less, limited entry makes a lot of sense to me. When you start going beyond that, 30 meters, 40, 60 meters frac spacing that you require due to perm or in situ fluids, I think, sliding sleeve or ball drop makes a lot more sense. Maybe my take, I think it.
And any just thoughts, Justin, on why more popular in Canada for sleeves than in the US? Any ideas?
I don't know. I don't know enough to make an educated guess. The one thing that came to mind is maybe there's a few, operating companies that kind of champion the sliding sleeve and like the predictability of it, you could say. Yeah, but I don't honestly couldn't say.
There are a few companies in the Montney that are highly devoted and dedicated to both ball drop and annular fracs, and those particular companies, you can't argue with their results. For sure, they're doing very well with those methods. So, very interesting conversation, and great to hear your thoughts on how you've landed on your chosen methods. Carolyn, any thoughts? Some of the operators that you've worked with, looking at their cores and then understanding what their completion strategies are?
Yeah, I mean, just regarding that one question from the US, it may come down to what Dan was talking about in that one paper, why they prefer plug and perf is like, the Montney is very unique in itself, and there probably isn't a really good analog in the States. And more often than not, the plays that they're playing down in the US are more Duvernay-like, and preferring that plug and perf is probably best where you have geomechanical issues. It's a lot less brittle, that kind of thing. So yeah, that may be the answer right there.
If I could just build on that a bit, I think, the Montney is also gassier and higher perm than a lot of the plays in the US, when you can afford to be a bit wider on your entry point spacing. So that kind of ties in with both Carolyn and Justin's comments there.
Yeah.
Great time for us to throw open the next poll question, Derek, if you're ready. And it's a question on developing the assets, and it's simply, what is your preferred completion strategy? And interested to see what everyone in the audience has to say about this. So take a moment and answer the question, and we'll come back to the answer. I want to follow up on now on something that Justin had mentioned, and I'm actually just personally very interested to know this question. Working at a service company where I meet, geologists and completion engineers and reservoir, and it was really kind of the genesis behind the whole topic of this conversation, the geological considerations of hydraulic fracturing. What is the methodology or the best practice for you guys from a communication standpoint internally for those interdisciplinary conversations that you were alluding to, Justin? And I understand, we have meetings, of course, we have emails, of course, I guess we're not meeting at the water cooler really these days because we're all at home, but really, is there any insight that you guys can give us into even workflows? How do you cascade ideas across the asset team? And maybe, Justin, you were talking about interdisciplinary decisions, and so maybe I'll get you to kick that off.
Sure. There's a lot of touch points among the teams for, bring up ideas, discuss previous well results, and as recently as we're starting to start doing more modeling, which, as I mentioned in my bio, which brings together a lot of different people from different backgrounds, and you can spitball ideas. But on a day-to-day basis, is mostly team meetings, I think, and look backs, And as our cost structures change every year, the budgetary process is a big one too. Capital, the way frac companies are changing their capital structures and everyone else, so it creates opportunities to try different things. I think it's an ongoing thing. I don't think, our per se doesn't have, certainly a structured approach. Every team kind of is differently, and every personality kind of does it differently. I think some people like to, vet their ideas through trusted coworkers before they kind of bring it up to the team. I think there's multiple ways that happens, but I think most teams have multiple touch points where ideas can be brought up. But the big ones are usually like structural, wholesale changes would be usually budgetary, long-term planning changes, and through modeling work, I guess. But that's not everywhere. Not all groups are doing that either. So that's my I guess non-answer answer. There's no.
It makes perfect sense. It makes perfect sense, Justin. It's not an easy question. It's really not. So Chris, I wonder, as a manager, you manage teams. How is there a way for you to ensure that everyone's voice on the team is heard? Justin mentioned personalities, and we all know that certain personalities can be more vocal than others. How do we ensure that everyone's ideas are getting heard across your asset team, across all disciplines?
It's a great question. In our industry, things change so quickly that how do we make sure that everybody's in touch with everybody? So at Ovintiv in 2018, we incorporated the agile process into our work. And the agile process or agile leadership, if you look up John Cotter, he talks a little bit about leading the agile leadership and help teams accelerate in a complex and complicated environment. And so what the agile process does is we meet every morning for 15 minutes, and there's over 100 people online at one time in 15 minutes. And we talk about the next most important thing for this company, and we make sure that it's being addressed in the next 24 hours. So our way is to get everybody committed to that 15 minutes, and we speak to the challenges of the day and make sure that everybody is aware. So that multidisciplinary approach, everybody has a voice and everybody is aware of what needs to get done the next 24 hours. So it's a fairly new approach in the oil and gas industry. It's been championed in the tech industry for a while now, but I've seen how quickly it transforms a company, and we've leveraged it and we continue to leverage it, and it's just a great tool for us.
And the topic on those conversations, Chris, is it something very, very specific to Ovintiv? Or is it something that you could share with us from a thematic standpoint, and what today's was, for example?
Yeah, so we talk about everything from execution to interfacing with regulatory bodies to managing budgets, communicating budgets, whatever the group or the team, the network team has identified as the next most important thing. That's what we discuss. So this time of year, if we're ramping up, there's a lot of execution type work that we'll be focusing on. Other parts of the year, we'll be looking at measurement issues or budget constraints or diagnostic pads, those sorts of things, look backs, learnings, whatever's next on our radar. It's just we all acknowledge that it's just a very complex business, and everybody brings a little bit of a different perspective to the table. And so to manage that quickly and effectively, it's just the tool that we choose to use.
That's excellent. Well, speaking of different perspectives, Derek, do you have the answer for us on various completion styles? Let's kick back to that for a second. Oh yeah, it looks like cemented plug and perf is clearly the winner. Open hole and sleeves drawing a relatively close second. And we all know that there are some operators who run those completion styles, and as we say, they're very successful. But we certainly at ProTechnics have seen a lot more people moving back to plug and perf over the last 2 or 3 years. So not a lot of surprises in this particular poll. Okay, I want to switch gears a little bit. There's one thing that we're hearing a lot about, and the question, maybe I'll start with you, Dan. Do you at 7G see a switch going on from more liquids-rich assets to gas-rich assets? Given commodity prices, we're seeing a lot of people pivot back to gas. If so, do you see that as a continuing trend?
Yeah, I think, my understanding of kind of the market fundamentals is the crash in oil prices recently has forced a lot of shale operators to shut in wells or ramp down activity. And, obviously they're always producing gas as a byproduct and selling it to the markets. And, now with the ramp down in activity, there's a lower gas supply. So, I think, maybe short term, yeah, you'll see some companies start to target, whatever is economic right now, because I think it's, by and large survival mode. But, I expect it to be relatively short lived, especially with things like vaccines coming to the forefront, and, we're seeing prices in oil rebound a little bit.
Justin, Chris, any comments on a pivot back to gas, or a pivot to gas, not necessarily back to gas, but a pivot to gas?
It just depends on your generation. It could be back to gas.
Yeah, that's right.
Go ahead, Justin. You want to take that, or do you want me to?
No, I got not much to add, to be honest. I don't look at the macro level that often at ARC. I get a sense of kind of just what Daniel said there. Other than that, I wouldn't have a whole lot to add, to be honest.
At Ovintiv, Kevin, I'd say we talk about this a lot right now. And I think one of the things that historically we've seen is we're usually the master of our own demise. And so I think what happens is we get so good at bringing back production as quickly as possible that those long-term pricing, those price fundamentals that Dan is sort of alluding to, I think right now they look strong, but we've already seen rig activity pick up. We've seen licenses in our leaner parts of the fairway pick up. And so operators are already doing this. And so the question we ask is how much gas has to be brought on before we see downward pressure on AECO differentials? And so we are cognizant of that and watching the market closely. But I also think it's tied to North America and LNG export in the US. So it's the supply side, like Dan said, the gas coming out of the Permian. And if it's being exported off North America, and if it's not, I think what you'll see is pricing will start to soften quite quickly if that doesn't continue the way it's going. So I think our best bet is to be agile and make sure that we have plans in place to respond quickly and effectively.
It's not always easy to do that, but certainly a lot of the companies that we're working with are making that change. So what geological characterization practices would you guys look at to help you determine what types of hydrocarbons are being produced? And any experience worth mentioning? What did you learn from that? So first of all, I'll throw that out to Carolyn maybe. What are geological considerations that a company might look at when trying to determine their liquids rich window?
Yeah, I mean, the easy and the fast one is always doing some geochem work, right? So I mean, Duvernay, geochem, Rocky Val, that is kind of typically where you're going to find your Tmax, that kind of thing. In the Montney, though, it did pose a little bit of a problem just because there is so little organic material in the Montney that Tmaxes were spurious and strange. So we actually found that vitrinite reflectance actually gave us a better indication of maturity windows. And so we've actually switched a lot of our kind of analysis within kind of the JIPs and the consortiums to looking at the vitrinite reflectance and what it's getting. And then ultimately it's confirmed by the operators and what they're actually producing at the end of the day. So.
Okay. Daniel, any thoughts on geological characterization regarding what type of hydrocarbons you think you're going to be producing from a particular pad or a particular well?
Sure. I guess, at a higher level, one of the most reliable things to do is just map up production. Now, the challenge there is operators are not obligated in Alberta to report condensate. So it's a bit of a challenge, but in that case, you need to kind of rely on flow test data, which is public information, as well as, you can look at investor reports and that type of thing to make sure you're concluding, I guess, what the operator is promoting. So, at a high level, for more of an exploratory or understanding your basin purpose, that is a cheap and accessible data set. And then I would say also, you can try and tie production relationships to things like routine gas analysis, which also is a requirement and gets submitted to the ADR and becomes public. So those are, my favorites for kind of evaluating regional trends.
I see Chris nodding. Any thoughts there?
Yeah, no, I think Dan has hit on it. I think, we look at HRGC, fluid inclusion. Maybe we continue to look at PVT analysis to try to understand our compositions and where those compositions are coming from. Understanding fluid phase behavior, migration, those sorts of things all help us understand where those yields are changing and how they're impacted by structure, porosity, those sorts of things.
Very good. I want to move topics just a little bit, probably our last topic for today. I want to just talk about the role of analytics, and maybe I'll throw this question out to Justin. Have you utilized and made any development decisions based on any real-time diagnostic technologies? And I know that you've used a lot of fiber optics in the past. Have you ever made decisions real-time based on that data or any other data sets you may have accrued?
Yeah, so for the fiber projects we've done, well, ARC's done 3, and I've been a part of 2 of them. On both, or maybe even all of them, there was some real-time decision-making going on for sure. So in most cases, we led with our fiber wells. We led the pad with doing fiber. We had a pretty good structure going into it, what we wanted to find out, what we wanted to try. And then based on those results, we then, in some cases, tweak the design going into the next phase, right? So obviously real time on the fly where you're watching, but then I think more what you're alluding to is real well design changes. And I guess the answer is yeah, we you know, in certain case, we saw a result that was better for cheaper. So we did a pretty good wholesale change in that case to in the second phase of that pad.
And Dan, have you guys at 7G, even from a geological perspective, have you guys done any real-time changes based on diagnostics that you've run?
Yeah, personally, yeah, I've never been the guy out there executing in the field. So, you know, the majority of my work analyzing some of the diagnostic information we've run has been, you know, post-job, and there's always a amount of time required to just compile data and get it together analysis. So, you know, I've always experienced a bit of a lag, but, you know, I think it is important just to, you know, when you're discussing these types of projects and pads, you know, to be upfront about how long is it going to take for us to, you know, pull the data together, analyze it, and, you know, incorporate it into results and, you know, other data sets, that type of thing. Because, you know, sometimes, you know, I've experienced pads or projects where by the time you've come to a conclusion, you've moved on, or you've abandoned your design or your mentality for the pad you've chosen.
Yeah, for sure. So how are geologists and engineers incorporating these days big data analytics and machine learning? Is it, you know, and would you say that you know, big data and data analytics and machine learning are critical to your business right now? Nice to have, or is it too early to say? Justin, I know you're just engaging in frac modeling these days, and there's certainly a lot of data analytics there. What's your experience?
Yeah, for data analytics, ARC's had a big push over the last year and a half or so in all disciplines to really get up the curve on machine learning, just data analytics in general. So we've had a couple of projects, all disciplines have their own, but in completion specifically, we have one individual champion it on our end. And I don't know if there's been any, you know, so far, like no eureka moment machine learning, like, wow, this machine's telling us this is what we need to do. We haven't had that yet. That's kind of the holy grail, I think, but we've had he's developed a lot of tools that makes our job, it makes us smarter and faster, I would say. So a lot of times you're digging through data, trying to find stuff, and you make, you know, best decision you can. But we've developed some tools now where we have data at our fingertips and we can make quick, accurate decisions. And that's been huge. I think it's man-hour savings, and just better decisions are certainly what we've seen, I think, so far.
Have you guys developed, Justin, any like internal dashboards using Power BI and so on? Yeah,
so we have internal dashboards for cost and frac, safety, some of which are Power BI, some of which are Spotfire. But yeah, so this one individual on our end, he, you know, works really closely with our IT department, or IS department, in developing this stuff, and anything from hazard IDs, which I know is not really the point of this ProTechTalks, operations side of it, but frac data as well. characterizing all that. Yeah, at our fingertips. Still working on stuff like predicting clusters, screen outs, and tying all the data we have together and getting the machine to tell us what to do is kind of the goal. But along the way, we've had a lot of big wins, I'd say.
Operations are not just, it's all interesting. It's all interesting for sure. Dan, I know we've worked on, personally, I know we've worked on a lot of data with you. What is the role of, data analytics and machine learning? And do you guys see it as critical? Is it nice to have or too early to tell at 7G?
Well, yeah, I think first of all, it's critical to have the ability to call up data sets, fast and effectively and be able to merge, have them communicate with one another. That's, in my mind, absolutely critical. And it's like, what Justin was talking about, just so you want to spend more time analyzing the data rather than compiling it at the end of the day. And even back to my initial statement on doing more with less, now that we're stretched pretty thin, having that ability, building those dashboards, yeah, definitely critical. And I think we also, as an industry, there's a lot of data that we essentially get for free or as, a byproduct of our drilling and our completion operations that, because it is such a large volume of data, it's almost historically been neglected, just sheerly due to the fact that it's really tough to manage. So, if we can work a way around that, we can, be able to map up or plot that data and yeah, really drive some learnings there at a very cost-effective price.
Chris, how does Ovintiv view big data analytics from both from an operations standpoint and from a geological standpoint?
Yeah, I think the guys are kind of hitting it. We think it's the future for our industry, understanding and leveraging big data, helping us become more predictable in what we're doing, looking for relationships, and then visualizing them either in a Power BI or a Spotfire type tool so we can understand the data and have confidence in the data that we're seeing and remove a lot of the bias that we typically introduce through conversations. I think that's important. And so we have teams now that are dedicated to data analytics, and that's all they look at and help us understand and execute more effectively and efficiently. For example, like there's the comment around, have we made decisions quickly? So we've created a dashboard system for our seismic arrays. So anytime we see induced seismicity, we pull our dashboard up and we look at magnitude and frequency and we start making real-time decisions around how we want to change things. So we're using that data, we're integrating it quickly, and we're making decisions to lower our risk and protect shareholders.
Well, I hate to say it, guys. We booked this ProTechTalks for just an hour, and this certainly could have been an hour and a half. I've got lots of questions left, and this is a really, really great conversation. But I don't want to impose on anyone's time. So, Carolyn, maybe I'll just get you to kind of finish up on data analytics and things that you guys are that we're seeing at Core Lab and ways that you're trying to help your clients with that kind of stuff.
Yeah, I mean, in terms of core analysis, we've had the databasing and Spotfire kind of integration for a number of years now, and I see more and more companies approaching us, regarding data and data analytics and how we do it. I know it's done down in the States quite a bit, but I think we're behind the bell curve on that a little bit, I think, up here in Canada. And it's just starting to gain traction because, we've been on this treadmill for a long time, of punching wells in and doing core analysis and getting data back fast. And nobody has really done anything with that data. I mean, I think we're sitting on a minefield, and I'm not just talking about public data. Companies are sitting on minefields of data that nobody has looked at. So, I mean, I think that's going to be kind of our biggest problem, is kind of wading through some of that data moving into the future. But yeah, AI and big data are going to be a big part of both service companies and operators, moving into the future.
It's great stuff, you guys. I want to thank all of our panelists. I want to thank Dan and Justin, and Chris and Carolyn for doing such an excellent job today. And thank you to all of our attendees. If you would like to see these ProTechTalks, and if any of our panelists want to see themselves in shining lights, just go to our website. These ProTechTalks are all posted at corelab.com /ProTechTalks, and you'll be able to go in and see all of them. Other than that, thank you very much for your time, guys. It was a true, genuine pleasure for me to moderate this for you. Thanks for your time. Thanks for your participation, and we'll sign off from there.
Thanks, Kevin.
Thanks, Kevin.
Thank you
Kevin.
very much, you guys. Thanks very much. Take good care. Bye-bye.